Hi there, welcome. So in today's lecture, we want to look out for other measures of dispersion. So we want to discuss the first three other measures of dispersion, which are quartiles, deciles, and percentiles. So let's begin with the first one, quartiles. So for us to understand the variation between the data sets and the mean, quartile is also another way for us to know the variation or the spread of data with respect to their mean. So for quartiles, quartiles help us to understand the data by dividing the data set in a groups of four. So you have something like, let's say Q1, Q2, Q3, and say Q4. So here we want to learn how to calculate these quartiles with respect to group and then ungroup data. So for an ungroup data, for us to calculate quartile, the first quartile, say Q1, should be equal to, so here it is a first quartile, and for quartiles, we divide the data set in the groups of 4. So you're going to have it as what? 1 over 4. Okay, in percentage wise, you're supposed to have what? 25%. All right, then that of what? Q2, you will have what? 2 over 4. Percentage wise, you get what? 50%. Then that of what? Q3, supposed to get 3 over 4. Percentage wise, supposed to get 75%. And then lastly, Q4, which is the same thing as what? Division by 1, you have Q4, where is 4 out of 4, and that should give us what? 100%. Just one division. So for quartiles, the general formula for an ungrouped data goes like this. You will have the general formula Qn, right, to be equal to, so you'll have what? N over 4 into bracket capital N plus 1 position. So the small n here represents the quartile you want to find. Let's say first quartile or second quartile. The n here, the capital N here represents what? The number of data sets to be considered. And this is the position we use to locate the data. So that means for Q1, we will have for the formula 1 over 4 into bracket N plus 1 position. That of 2, we will have what? 2 over 4 to bracket N plus 1 position. Then that of 3, you will have 3 over 4 to bracket N plus 1 position. And that of 4, you will have 4 over 4 N plus 1 position. But as per the discussion, you're going to consider the first three, first quartile and then the third quartile. So the first quartile is also called the lower quartile. Second quartile is also called the median or the middle quartile. Then the third quartile is also called the upper quartile. So here, once we have this, that's the formula for ungroup data. So for that of group data, so this is what? Ungroup. Ungroup data formula. For that of group data, you will have what? The general formula here as, like, say, Qn to represent the lower quartile, right, plus open bracket N over 4 multiplying frequency minus the cumulative frequency of the quartile class divided by the frequency of the quartile and then multiplied by what? The class size. So that is for the group data formula. So let's take an example to explain these formulas that we have talked about, ungrouped and then grouped. So let's say we have the following data. We have, let's say we have 4, 3, 2, 5, 4, 6, and let's say 7. let's say we have this set of data coming up as an ungroup data. So based on this data, we are asked to find what? Q1 and that's of what? Q3. So how do we go with Q1 and then Q3? So before we can find Q1 and Q3, we need to arrange the data in ascending order. So in ascending order, you will have in ascending order, supposed to start with what? 2, followed by 3, then we have 4, another 4 coming up, we have 5, 6, and then what? 7. So that means for Q1, once to identify Q1, we'll have to locate the position of what? Q1. So that's going to give us what? 1 over 4 into bracket. We know the numbers here is 7. 1, 2, 3, 4, 5, 6, 7. So you have 7 plus 1 position. So what do we get? Here you're going to get here as 8. So get 2. That's the second position. So for us to get a quartile value, right, it means it falls in the second position. So in an array, you will have 1, 2. So that means the first quartile, which is Q1, the lower quartile is what? 3. Then you are true. Right? And that of Q3, 2, we will have here as what? 3 over 4 into bracket 7 plus 1 position is supposed to get what? So here, you're going to get 6, I guess. So here going to give us what? 8. So you get 6. So 6 position. So 6 position here, you have 1, 2, 3, 4, 5, 6. That's the 6th value. You have it here as what? That of what? Q3, the upper quartile. And you are true. But one aspect of this quartile is where you have, let's say, the position to be in a form of what? A decimal. So let's assume that after we finding Q1, we had the position of the Q1. Let's assume that we have the position of the Q1 to be, like, say, 2.5. So 2.5 position as a position. So here, how do you find the actual value of what? Q1. So this is what you're going to do. You know that here is a combination of 2.5 is the same thing as what? 2 plus what? 0.5. So that means that the Q1 or the lower quartile or the first quartile is in between, the value is in between what? The second position and the next what? Position, as opposed to the third position. That's why you're having 2.5 here. So that means for us to get the Q1 value, is fall between the second value and then the third value because of the decimal. So how do you go? We will say that here, for us to find the value itself, then we know that here is 2.5. That will be, the 2 here will be the second value. So let's say you have 3 here. Okay. So you have 3 here. And for us to get the actual value of what? Q1 is going to fall between what? The second position and then the third position. So this is what you're going to do with the decimal. You're going to say that you have 0.5. Then you find the difference between what? The next value, which is the 4 here. Then you subtract the second value, which is 3, from it. And whatever you're going to get will fetch us what? Our Q1. So you have here as what? I think 3.5. Then you are true. Let's also assume that Q3 had, let's say, a value of, let's say, 6.7 as our position. In terms of decimal, we had 6.7 position. So how do you find that? So the same thing, here you locate the 6 value. So you have 6 plus what? 0.7 position in that particular guide, right? So that means Q3 value will fall within what? The 6 value and then the next value that comes after the 6. So here we have 1, 2, 3, 4, 5, 6. So you have the 6 here, and then that means the actual value of Q3 will fall between the 6 value and then the next value. So that's going to give us what? Plus. Then you have your 0.7 multiplying the difference between what? The next value and then the 6 value here. As always, right? So depend on the mark or the position that you get, that will tell us where the difference will come from, right? So you're gonna get here as what? So the difference is 1, so you get what? 6.7, and you are true. So that's how it goes with what? Q3. All right, so when we have this math, that's how you're supposed to approach it, and you're good to go. So that is for the quartile on group. But for the group, if you have a group data, let's say we have what? This group data coming up. Let's say we have what? 4 to, let's say 6, let's say 7 to 9, okay, then 10 to, let's say 12. All right, let me add last one. Then let's say we have 13 to what? 14. These are the marks, right? And let's say the frequencies for these marks. Let's say we have here to be 2, 4, 6, and let's say here is 5. So once we have their frequencies here, then we are asked to find what? Let's say Q2. That is what? The middle quartile. The middle quartile. This is a group data. So how do you find the middle quartile? So first I have to locate to the total frequency in here. So we have 4 plus 6, 4 plus 2, which is what? 6 plus 6, we have 12, plus 5, we have 17. So let's say we have what? A set of data to go 17 here, as you can see. So that means that for us to locate the position of what? Q2, supposed to be what? 2 over 4 into bracket the frequency involved. So here you will have the position to be in the form of what? Multiplying summation what? F. That is how the frequency for group data goes in terms of locating the position for Q2 or for the quartile generally. So here, what do we get? You'll have 2 over 4 is the same thing as what? 1 over 2. So you have 1 over 2 multiplying 17 is supposed to get what? Here is supposed to get 8.5 position. So that means here we need to find also our cumulative frequency. Cumulative frequency for the frequency. So for the cumulative frequency, we know the first one will give me 2. Second class supposed to give me 6, so we'll just be adding them. Then third will give me what? 12. And then fourth will give me 17. And that shows that I'm correct. Because the total frequency give me the last cumulative frequency of 17. And it's true. And you know that formula-wise, Q supposed to be equal to, as a quartile, for group they're supposed to be equal to the lower class boundary plus n over 4 multiplying the frequency minus the cumulative frequency of the quartile class divided by what? The frequency of the quartile, and then multiply by what? The class size. Okay. So that is how you go generally here. So here we need to have also a column for, we need to have a column for that of what? The class boundary as well. So you have our class boundary coming up here and possibly our class size. Okay, so for class boundary, as always, here the common point is what? 1. The common point is 1, 1. So once you get 1, subtract 6 from 7, get 1 divided by 2. 9 from 10, same 1 divided by 2. So you get 0.5 as such. So add and subtract. You add to the upper class and subtract from the lower class limit. That's how you go for the class boundary. So since we are interested in what? The quartile, the middle quartile of Q2, and we have located that the position is what? 8.5. That means that the 8.5 is going to be in between what? Going to fall between what? The third class limit, because the cumulative frequency of the second class is 6. So that means we can get what? 8.5 within what? The class limit of 10 to what? 12, right? So we have to find a class boundary for that as well. So you'll have here the class boundary here to go 9.5 to 12.5, and you are true. So we add 0.5 to this, we subtract 0.5 from 10, we add 0.5 to 12, and you get this. Okay, and for us to get our class size, is the difference between what? The upper class boundary and the lower class boundary. So what do we get? 12.5 and 9.5, supposed to get what? Is it 3? You're supposed to get 3 in that case, and you are good to go. You're supposed to get 3. So you're going to get here as what? 3 as our class size. Okay, so once we have that, then we can say that therefore Q2 per formula Y is supposed to be equal to, so lower class limit of the class, that of the Q2 supposed to be what? 9.5. So you have 9.5 coming up here, plus then you have, we know n is 2 over 4, and we know the frequency to be what? 17. Okay, then what's the cumulative frequency of the quartile class? It is what? 12. So you have here as 12, all divided by the frequency of the quartile class, which is what? 6. Here you can see here 6. All multiplying the class size of what? 3. So whatever you get for the addition of 9.5 and what is in the bracket, that will give us what? The quartile for Q2, or the middle quartile, and you are good to go. And this is how we calculate for what? That of what? The group data for quartiles, whether Q1, Q2, or Q3, and you are good to go. And one last thing under quartiles is what we call interquartile range. Interquartile range is also another way for us to measure the variation between the data and the mean. Interquartile range is computed as what? The upper quartile minus the lower quartile. Upper quartile is Q3 compared to lower quartile Q1, and you get your interquartile range. So let's take note of that. Let's take note of that. So I'm using to calculate Q3 and Q1, whether it's group or ungroup, and then the difference will give us the interquartile range. So let's take note of that. So that was on the quartiles issue. So the next thing we want to look out is the deciles. So deciles here too is also another measure of dispersion. So let's bring in deciles. So 2 deciles. Deciles. So deciles, you want to have a division of the data set in a group of what? 10. So you'll have what? Say D1, okay, D2, D3, 3 dot, D to the power, D subscript 10. So that means you have for division of what? The data in a group of what? 10. Okay, so for an ungrouped data, for me to calculate, say, D1, I will say that D1 will give me what? 1 over 10. And follow the same principle as that of what? The quartile. So you're going to have here 1 over 10 multiplying n plus 1 position. Right? If it is D2, you have what? 2 over 10 multiplying n plus 1 position, where we're using the capital N to represent what? The total frequency under consideration. So that means that in summary, Dn supposed to give us what? N over 10 multiplying the n plus 1 position. That is for what? An ungroup what? Data for deciles in a group of 10. So ungrouped. So let's take note of that. If it is group 2, then it follows the same logic as the quartile for group. Just that here, we're going to change their what? Representations or the variables that we have used in the quartile. So for deciles, we will say that D for the decile, if it is D1, D2, whatever it is, supposed to give us what? The lower class boundary of the decile class plus, then you have what? You have n over 10 multiplying the frequency, right? Total frequency minus the cumulative frequency of the decile class, divide all by the frequency of the decile, and then multiply by what? The class size. And you are true. So that's also decile also what goes when it comes to decile. So the same approach that we have used to calculate that for the quartiles, for group and ungroup, we follow the same principle, right? Just that their names change here depend on the measure that you are considering, whether it's quartile, decile, or the next thing you're going to discuss, which is what? Percentile. So this is also what we call what? Group what? Data formula, grouped. Grouped. So use the same principle. So if you are asked to find, let's say, D5, D5 will mean that you have what? 5 over 10, right? You use that to multiply the frequency under consideration so that you can locate the position of the data. If it's group or ungroup, the same principle, then you are good to go. So let's take note of that. And lastly, we'll talk about the third one, which is called what? The percentile. 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 So percentile 2, you want to have the division of data in a groups of what? 100. In a groups of 100. So that means we will have what? P1 up to P100, right? But for the most part, we have the lower percentile, which is P1, then the upper percentile, which is what? P99, right? So follow the same logic. If it's for ungroup data, you will have your Pn to be equal to your small n divided by 100 multiplying what? Your capital N plus what? 1 position. This is for what? An ungroup. So if you have, let's say, P20, then you're going to have 20 over 100, okay, multiplying the frequency that you'll be given in the question, add 1 to the frequency for us to find the position, and you are true. This is how we calculate for what? An ungroup data, okay, ungroup data. So ungroup data, you will have this formula coming up. Then that of grouped, you will have your P, say subscript N, to represent the percentile you want to consider, and that should be equal to the lower class boundary of the percentile plus into bracket N divided by 100 multiplying the frequency, the total frequency under consideration, minus the cumulative frequency of the percentile class divided by the frequency of the percentile, and then multiply by what? The class size or the class width. So you see that it's the same thing for the formula, the same pattern. Just that the pattern or the measure will change depending on what you are considering, whether you are considering quartile, deciles, or percentiles. So the same pattern of the formula for both group and ungroup for these 3 measures of dispersion: quartiles, deciles, and then percentiles. So this also represents what? Group data aspect, grouped. And you are true. So that is the whole idea when it comes to these other measures of dispersion, which are we have discussed generally here as what? Quartiles, deciles, percentiles. So in summary, we said quartiles are data sets in a groups of what? 4. Deciles are data sets in a groups of what? 10. And percentiles are data sets in a group of what? 100. So for quartiles, we have both group and ungroup, and we have discussed their formula, as you can see here, right? And then for that of deciles, we also talk about that. You can see their formula also here, both group and then ungroup. And that of percentiles too, the same pattern of the formula, just that the change of names comes in. Depend on the measure of dispersion you are considering, the same pattern for group and then ungroup and then what? Group. So let's take note of that. So thank you for watching. I'll see you in the next section. Bye-bye.